So in this problem, we have to find the domain and range of the function of two variables given by a rule. So before we actually solve this problem, let us first see what is a function of two variables and how do we define its domain and range. Function of two variables from a set, say A cross B, to another set C, is a rule which assigns each element xy in A cross B to a unique element z in set C, and the rule is given by z is equals to a function of x and y variables. Now if these A and B sets are given, then nothing doing. A cross B will be the domain of this function. But this is not the case here. We are only given the rule of the function, that is how to find the domain of a function when only rule is given. And the golden rule is that suppose the domain is denoted by D, so the domain of function is collection of all ordered pair xy such that, so it's a collection of all those xy values for which the expression, and the expression is the rule. In this case, the expression is 9 minus square root of 9 minus x square minus y square is a well-defined real value. So what does mean by well-defined? Well-defined means we should not have situation like something over 0, because in mathematics division by 0 is not possible, right? And this z value should be a real value. Like in this case, this expression inside the square root, it should be a non-negative value, because square root of only a non-negative number is a real number. So we should keep these two things in mind while finding the domain, that we should select xy in such a way that the z value is well defined and it should be a real number. Now going back to our problem. So in this problem, the rule is z equals to square root of 9 minus x squared minus y squared. Now suppose domain we are representing by set D. This will be collection of all xy points such that this rule is well defined for z. So now when will be z well defined and it will have a real value in this case? If the expression inside the square root is a non-negative number. Okay, so only those xy points are allowed for which 9 minus x square minus y square is a non-negative number, that is greater than equals to 0. Now we'll solve this inequality. 9 minus x square minus y square greater than equals to 0. It means 9 is greater than equals to x square plus y square. It means x square plus y square is less than equals to 9. So domain will be collection of all those xy point which satisfy this inequality. So our domain will be collection of all xy points such that x square plus y square is less than equals to 9. Now we can geometrically visualize domain of this function, right? Now domain consists of all these ordered pair. It means the domain will lie in two dimensions. So suppose this is x, we have y axis. X square plus y square equals to 9 is the equation of a circle. Less than equals to 9 means a closed disk. So we are drawing this closed disk roughly. So this one is the closed disk. So all the points lying inside and on the this disk, this denotes the x-axis, y-axis, and this dotted region entire denotes x square plus y square less than equals to 9. So this point will be 3, 0. This point will be minus 3, 0. This point will be 0, 3. And this point will be 0, minus 3. So geometrically, all these xy points in this closed disk in xy plane, they form the domain of the given function. We have to find the range of the function. Okay. Now, whereas the domain is a two-dimensional region, the range is a one-dimensional region, right? What is range of f? This is collection of all z points in set of real numbers such that z is getting value from this rule 1 9 minus x square minus y square, and x and y are taking values from this closed disk. Now, first thing, z is square root of a real number, and square root is a positive function. Okay, so it's a non-negative function, right? So z can take values in the interval 0 to infinity only. Square root always gives us negative, non-negative values, right? Now the question is, does the range this entire interval from 0 to infinity? And here lies the catch. The what will be the minimum value of z? The minimum possible value of z is 0, right? What will be the maximum value of z? Now let us go back to our rule. What will be the z maximum value of z? Z will be maximum when the x value and y values are minimum. And what is the minimum value of xy ordered pair? It will be when x is 0 as well as y is 0. It means the origin, the point at origin, right? So the maximum value of z is that is square root of 9, that is 3. Okay, so we have range of range of f equal to collection of all z values such that z belongs to interval 0 to 3 close interval, or simply we can write it as close interval 0 3. And we can visualize the range. Suppose this number line is represents z, this one is origin here. So the domain will be, the range value will be from 0 to 3. So this interval from close interval 0 to 3. Thank you.